In this video we will be talking about the ampere, which is the SI base unit of electric current. It is defined by the symbol capital A, and this was the name ampere itself was named after the French mathematician and physicist Andrew Marie Ampere. So this is the physicist who was named after the SI base unit of ampere. So let me just write it down. It's his name. It was named after Andre Marie Ampere, and he is also considered as the father of electromagnetism. So first of all, we will go through the history of electric current. So first of all, the relationship between electricity and magnetism was first discovered by a Danish mathematician and physicist Hans Christian Ørsted in 1820. In 1820, in 1820, by this person, the Danish mathematician and physicist known as Hans Christian Ørsted. So what he discovered, that if you put a compass near a wire which is carrying electricity, then that compass will deflect, because of the reason that the wire which is carrying the electricity is actually producing a magnetic field. So he discovered that there is a close relationship between electricity and magnetism. The wire which is carrying the electric current is also generating a magnetic field. So later on, the Andrew Marie Ampere Andrew Marie Ampere worked on the relationship between electricity and magnetism. So what he found out, that if you take two wires and place them parallel to each other, then and pass electricity through them, then those wires will repel or attract depending on the direction of the current. So if you have two wires, then if you have and if the electricity is flowing through them, then they are generating a magnetic field which will either attract or repel depending upon the direction of the current in those wires. And you will see later in this video that why it wasn't the ampere was named after Andrew Marie Ampere, because due to his experimentation, due to his finding, his name is honored in ampere. So the up to 2019, the SI definition for the ampere was, let me just place it here. So this is the definition of ampere. Here you are. So this is the ampere is that constant current which, if maintained in two straight parallel conductors of infinite length of negligible circular cross section and placed 1 meter apart in vacuum, would produce between these conductors a force equal to 2 multiplied by 10 power minus 7 newtons per meter of length. So I'm sorry, let me just put it aside to explain it you in more detail. So what the definition is saying, this definition is based on Andrew Marie Ampere's experimentation, that if you have two wires placed parallel to each other of infinite length, so let's just say these wires are of infinite length, and if you place them 1 meter apart, say they are 1 meter apart, and if you and there is electricity going through these wires, then these wires are generating a magnetic field. So these wires are actually generating a magnetic field, which will repel, which will exert a force, the repelling or attractive force, depending upon the flow of the current in the wires. If the flow of electricity in these wires are in the same direction, then they will repel, and if they are in opposite direction, then they will attract. So I'm gonna just write it down. So they are generating a magnetic field. So if the direction is same, then they will repel, and if it is opposite, then they will attract. And how much force they will exert? Well, they will exert about, so they will exert about, sorry about that. So they will exert about 2 multiplied by 10 power minus 7 Newton per meter of length. So they will exert this amount of force when they are placed parallel to each other, and they are about 1 meter apart in a vacuum. And if there is electricity running through those wires, and then they will exert to each other a force of about 2 multiplied by 10 power minus 7 newtons. So this was the definition until 2019, and then the new definition was changed, and then the new definition eventually replaced this definition. So just a little bit through history we will go. Just right now I'm just gonna put this diagram aside. So let me just resize it. Here I just resized it, and now we will go through the before the this definition that was until 2019, because even before there were some definitions of the ampere. So I will go through that definition. These few of the definition which are actually really practical ones, unlike this definition or the new one that we have. So in 1893, in 1893, a scientific committee known as International Electrical Congress. So the International Electric Congress settled on two units that will be used for the basis of other units, and these were ohm, and then we have the ampere. Ohm for resistance, and ampere for current. So this ampere is actually known as the international ampere. So what is the definition? What's the difference between ampere and the international ampere? Well, not these are just the same, but the international ampere was unlike unlike this definition of the ampere or the new one, it was more practical. So it can be determined in a very practical manner. So how the international ampere was determined? It was determined using a silver voltmeter. So it was determined or measured, I'm sorry, the correct word will be measured by silver voltmeter. And yes, I've just said voltmeter, not voltmeter. So what's the, so this is common misconception. So there's a difference between voltmeter and voltmeter. So what does voltmeter do? So first of all, let me write down the voltmeter, and then we have voltmeter. So voltmeter is used to measure electric potential, and voltmeter is used to measure electric charge or current. So in order to measure the international ampere, the silver voltmeter was used. So how does silver voltmeter works? I'm gonna show you right now. First of all, let me just erase the whole history part, because you guys already know we are in the history right now. So what is silver voltmeter do? Let's just have a grayish type of color. So let's say that you have a silver voltmeter is based on silver nitrate solution. So let's say we have silver nitrate solution here. So this is the silver nitrate solution, say silver nitrate, and then we have two electrodes here inside it. We have two electrodes, which is one is anode and the one is cathode, which is positive. Anode is negative. Anode, cathode. So if you run electricity through current through them, then the silver in silver nitrate will get attached to the cathode area. So from this the ampere was defined as the current that would deposit 0.001118 grams of silver per second from the silver nitrate solution. So silver from the silver nitrate would just would just gather up through the cathode area. And the definition for that, for the practical ampere, for the international ampere, was the current that would deposit 0.001118 grams of silver per second. From the silver nitrate solution. So let's just put this little diagram to a side, resize it, and just put it here. So the definition for the international ampere was that the current that would deposit 0.001118 grams of silver per second. This was the definition for the international ampere. But with the introduction of more and more accurate measurements, it was found that the current was less than 1 ampere. So this value was a bit off. It was not accurate. So then, how the silver voltmeter was calibrated? Well, it was calibrated using a Western cell. Calibrated by Western cell. So what is Western cell? So a Western cell is a device that is used to generate a very stable voltage. So if you have a very stable voltage, and then you attach a resistor of non-resistant, you attach a resistor which whose resistance you know, then you can very accurately calculate the ampere, then the current, and that will be used to calibrate the silver voltmeter. So the in 1921, the international the General Conference on Weights and Measures formally added the ampere. At that time in 1921, ampere was the fourth SI unit. Fourth SI unit, it was the ampere. They formally added the ampere, which was basically the international ampere, but the scientists already knew about the inaccuracies, the inaccuracy of that international of the international ampere, the silver voltmeter, and its inaccuracy, and they knew that it wasn't accurate enough, and they needed a new definition. So then in 1948, the International Committee on Weights and Measures adopted the new definition that was based on Andre Marie Ampere's experimentation. So the new definition was based on Andre Marie Ampere's experiment, and that was the definition. This is the definition that I told you about, and it remained until 2018. 2019, same. At that time it was beginning to change. You can say it started on at 2018. So the ampere was this at that time. At this whole timeline, the ampere was based on Andre Marie Ampere's experimentation, and it remained so. But in 2018, the General Conference on Weights and Measures agreed that on 20th of May in 2018 they agreed. So this timeline was for Marie Ampere experiment definition. And then in 2018 they agreed that on 20th of May 2019, the ampere, the new definition of there will be a new definition of the ampere, and that definition will be defined as, now I'm just gonna raise it all down. And that definition will be as, let me just get that definition for you guys. So that definition will be this definition: the ampere is defined by taking the fixed numerical value of the elementary charge E to be 1.602176,634 multiplied by 10 to the power minus 19. When expressed in the unit C, which is coulomb, here C is for coulomb, the SI unit of charge, which is equal to AS, A for ampere and S for second, where the second is defined in terms of delta VCS meaning like this, VCS. CS stands for the cesium, the unperturbed ground state hyperfine transition frequency of the cesium 133 atom. So I made the video about the cesium atom, how 1 second, how a second is called a second. So make sure to check that out. So here delta VCS basically means that about that the 9 billion vibration oscillations of the cesium 133 atom. So if so when it vibrates about 9 billion times, then it's called 1 second. So unperturbed here means undisturbed. So make sure to check that video out. So let's not go into this detail, shall we are here for this detail, the which is the taking the fixed numerical value of the elementary charge E to be 1.602176,634 multiplied by 10 to the power minus 19 when expressed in the unit C. So it seems like the ampere is attached to another fixed numerical value, charge E, to be this times. So here I want you to focus on these numbers. So it is saying the value of elementary charge E to be this number when expressed in the unit coulomb. So this whole digit, these numbers are very interesting numbers, because why? Because we know what is electricity, flow of electrons, right? So this is actually the charge of an electron, which is right. Can I write it down? Charge of electron, which is charge of electron. So electron has, the charge on electron is about 1.602176,634 multiplied by 10 to the power minus 19 coulomb. So this is the charge of this whole value, this whole fixed numerical value is actually the charge of an electron. So how the charge of electron was determined? So it was determined in 1909 by Robert Millikan and Harvey Fletcher. Harvey Fletcher in the oil drop experiment. So the whole experiment was named as oil drop experiment. So from oil drop experiment, they um, they derived the charge of an electron. So the whole oil drop experiment, I will make a video on that later in the later chapters when we go through the physics chapter step by step. So the charge of electron is about this whole numerical value, and C is for coulomb. So here it's saying the elementary charge. So charge and coulomb is the coulomb actually is the unit, the SI unit of charge. So I'm just gonna take this value and okay. Okay, so the charge, the coulomb is actually the SI unit of coulomb is actually the unit of charge, and the coulomb is defined by the quantity of electricity in carried in 1 second by a current of 1 ampere, so which is the quantity of electricity carried in 1 second by a current of 1 ampere. And the whole equation is given by, so let's just take this value because we're gonna need it after in the end. Okay, and then we have this charge. So I'm gonna just remove this, the determination of the charge of an electron by the Oldorf experiment. So what this definition is actually trying to say in equation a charge is actually given by the equation Q equal to IT, where Q is the charge, I is for ampere is the current, and T is for time, which is given by second. So when you convert their into their base into the SI units, it becomes coulomb. 1 coulomb equal to 1 ampere, and T is for time, which means second. So that means, so if you take S to the other side, it becomes divisible. Then it becomes 1 ampere equal to 1 coulomb per second. 1 coulomb per second. So 1 ampere, so the definition of ampere becomes the current of the definition of 1 ampere becomes 1 coulomb of charge per second going past through a specific point per second. So this is the, so this equation is actually the new definition, as the new definition of ampere. So which is a current, a current is 1 ampere if 1 coulomb of charge is going past a point, given past a point per second in 1 second. So I'm just gonna again take this value because, oh, sorry about it, because of the fact, because I find this quite interesting. Let me just resize it here. So actually it's saying electron, the charge on electron is this much value. So here we have 1 coulomb, of charge. So if you take this value and it becomes divisible, so it becomes 1.602. Just take it till 7, and we have 10 to the power 19 equal to, and this becomes 1 coulomb. So 1 coulomb becomes approximately 6.24 multiplied by 10 to the power 18 electrons. So the definition of another definition of ampere can be at a current is 1 ampere if 6.24 multiplied by 10 to the power 18 electrons are going past a point per second. 1 coulomb of charge, or this many electrons going past a point in 1 second. So that's how many electrons are equal to 1 coulomb of charge. That's really insane. Yeah, you have 6.24 and then we have 18 zeros, and that's how many electrons take for 1 coulomb of charge. So This is the whole definition of ampere. I hope I didn't missed some important details, but I think, yep, this is it. This is the new definition. This is the now the new definition of the ampere. The beneath one was until 2018 19. So this definition was based on Andrew Mary Ampere's experiment here. When you take about when you take in when you take wires of infinite length and pass electricity through them, then they will generate magnetic field in when you take them in vacuum parallel to each other, and the distance between them is about 1 meter, and then they will produce a force equal to 2 multiplied by 10 power minus 7 newton meter. So I I'm sorry about this, but I think I'm sorry. I'm sorry about it, but I think I forgot something. You will be noticing about this. You will be confused about it. It's saying of negligible cross circular cross section. So what does that mean? Of negligible cross section. Negligible meaning a value so small that it can be neglected. So what does it mean by circular cross section? So let me tell you a quick demonstration. So these wires are from the sideways. So when you see some wire from sideways, it is just like a line. Okay, so if you take when you take this thing, when you take that wire in front of you, it becomes something like this. It becomes a circular cross section, right? So it's saying, let me just make it big. Okay, so okay, so this is the circular cross section. So it's saying that negligible cross section, which basically means a cross section so small that it can be neglected. So here we have very big cross section, which means that where the wire is very big. So if you make it small enough that the cross section becomes so small here, just like this, that it becomes negligible. So this is what it's saying. So thank God I I, I just read the definition, and here I forgot about this statement. Uh, that's why I was thinking, did I forget something or anything? So I think that covers basically all. So this is the new definition. This was the previous definition, which was based on Andrew Mary Ampere's definition. This whole experiment, and now the definition is based on taking the elementary charge E, which is the charge of an electron, to be this value when you have in coulomb. So it becomes, so the definition of 1 A becomes 1 coulomb of charge going past a point in 1 second. And you can basically also say that 1 coulomb 1 ampere is about 6.24 multiplied by 10 power 18 electrons going past a specific point in in a second. So I hope you have found this video very informative, and if you have found it, then please like and subscribe to my channel. And in the next video we will talk about Kelvin. So the just a sneak peek for the next Kelvin video. The Kelvin videos, the history of temperature is basically very huge. So I think mm, I'm gonna divide the whole video up in two parts. First part will be about the whole ancient history, and then the second part will be about the modern, when the area of temperature, when it became more modernized, when Celsius, Fahrenheit, and Kelvin be, Kelvin came through it. So I'm gonna just prepare that lecture video as well. So I hope you have found this video informative, and if you do, like and subscribe to my channel, and I'm gonna see you soon in the next video. Thank you so much.